Hi there, welcome in. I'm so glad you made it here today. Before we get started, I'd love to hear where you're tuning in from and what time it is for you. It's such a treat to see the variety of places and times represented in this community. I also want to gently thank those who have subscribed and clicked like on the videos they enjoy. It really helps this space grow. And of course, if you have ideas for new content, I'd love to hear them in the comments. With that, let's begin. Chapter 1: Understanding Black Holes, Nature's Cosmic Enigma. In the vast expanse of the cosmos, where stars twinkle like distant candles in the night, black holes stand as profound enigmas, challenging our understanding of the universe. To define a black hole is to confront the very fabric of reality itself. A black hole is a region in space where the gravitational pull is so intense that nothing, not even light, can escape its grasp. This extraordinary phenomenon occurs when a massive star exhausts its nuclear fuel, leading to a catastrophic collapse under its own weight. Imagine a once vibrant star, shining brightly in the cosmic tapestry, now reduced to a singularity, an infinitely dense point where the laws of physics as we know them break down. As we explore further, we encounter the various types of black holes that roam our universe. The first, and perhaps most familiar, is the stellar black hole. These are born from the remnants of massive stars after they have undergone supernova explosions. The core collapses, and if it has sufficient mass, it compacts into a black hole. It is a fascinating process, one that highlights the delicate balance in the life cycle of a star. Then we have supermassive black holes, which lurk at the centers of galaxies, including our own Milky Way. These colossal giants can be millions or even billions of times more massive than the Sun. Their formation is still a subject of intense study and debate among astrophysicists. One prevailing theory suggests that they grew from the merging of smaller black holes and the accretion of gas and dust over billions of years. Imagine a cosmic whirlpool, drawing in everything within its reach, influencing the orbits of stars and the very structure of galaxies. Lastly, primordial black holes are a tantalizing concept. They are believed to have formed in the early universe, shortly after the Big Bang, through high-density fluctuations. These black holes may vary significantly in size, potentially ranging from tiny to incredibly massive. Their existence remains largely hypothetical, yet they offer a captivating glimpse into the conditions of the universe during its infancy. At the heart of each black hole lies the event horizon, a boundary beyond which no information can escape. This threshold marks the point of no return. Picture it as a dark curtain drawn across the universe, where anything crossing this boundary is lost to us forever. The event horizon is not a physical surface, but rather a point in space-time. It serves as a reminder of the limitations of our understanding. Once something enters a black hole, it becomes irretrievable, its fate forever sealed within the mysterious depths. The significance of black holes extends far beyond their shadowy allure. They play a crucial role in astrophysics by helping us understand the workings of the universe. Their immense gravitational forces shape galaxies, influence star formation, and even affect the cosmic microwave background radiation, a remnant of the Big Bang. Black holes challenge our perceptions of time and space, suggesting that under extreme conditions, the very fabric of reality can warp and bend. Renowned physicist Albert Einstein once remarked, "The most beautiful experience we can have is the mysterious." Black holes embody this mystery, inviting us to ponder the nature of existence itself. They remind us that the universe is vast and filled with unanswered questions. What lies beyond the event horizon? How do they form, evolve, and interact with their surroundings? As we contemplate these cosmic wonders, we realize that black holes are not merely celestial phenomena, but are also keys to unlocking the secrets of the universe. They urge us to push the boundaries of our knowledge, to explore the depths of space and time. Each discovery we make leads us closer to understanding these enigmatic entities, revealing the intricate web of connections that weave through the cosmos. In the soft glow of distant stars, we find ourselves drawn to the mysteries of black holes. They beckon us to listen to their silent stories, to embrace the unknown with curiosity and wonder. Each question we ask leads us deeper into the cosmic narrative, where the boundaries of science and imagination blur, and the mysteries of the universe unfold before us like the petals of a celestial flower. What is it about black holes that captivates our imagination? Perhaps it is their sheer power, the way they warp space-time, or the secrets they hold about our universe's birth and eventual fate. They remind us of the fragility of existence and the boundless curiosity that drives humanity to seek answers. Each time we gaze into the night sky, we are reminded of our place within this vast expanse, where black holes stand as guardians of the unknown, urging us to explore further and dream bigger. In the grand tapestry of the cosmos, black holes are not merely voids, but rather integral components that illuminate the dynamics of galaxies and the evolution of cosmic structures. Their influence extends far beyond their immediate vicinity, affecting the behavior of stars and even the formation of new celestial bodies. As we uncover the intricate relationships between black holes and their environments, we gain insight into the forces that shape our universe. These enigmatic entities also serve as natural laboratories for testing our theories of gravity and the fundamental laws of physics. The study of black holes has led to groundbreaking developments in our understanding of general relativity and quantum mechanics. The collision of these two realms highlights the need for a unified theory that can account for both the macroscopic and microscopic behaviors of the universe. The pursuit of knowledge surrounding black holes is not solely an academic endeavor. It is a journey fueled by wonder and a desire to comprehend our place in the cosmos. Each discovery brings us closer to unraveling the mysteries that have fascinated scientists and dreamers alike for centuries. As we continue to explore these cosmic enigmas, we are reminded of the words of physicist Stephen Hawking. The greatest enemy of knowledge is not ignorance, it is the illusion of knowledge. With each step forward, we peel back the layers of understanding, revealing the depth and complexity of black holes. They challenge us to embrace uncertainty, to question our assumptions, and to pursue the unknown with relentless curiosity. As we stand on the precipice of discovery, we recognize that the journey is as important as the destination, for it is in the pursuit of knowledge that we find meaning and connection in this vast universe. As night falls and the stars emerge, take a moment to gaze up at the heavens. Imagine the black holes hidden amongst the twinkling lights, each one a silent sentinel in the cosmos, holding secrets older than time itself. What stories do they have to tell? What insights might they offer us about the nature of existence? The night sky is a canvas painted with possibilities, inviting us to dream, to question, and to explore the unknown depths of the universe. As we contemplate the profound influence of black holes, it becomes clear that they are not mere cosmic oddities, but central players in the grand drama of the universe. Each type of black hole offers unique insights into the workings of space and time. Stellar black holes provide a glimpse into the life cycle of stars, while supermassive black holes challenge our understanding of gravitational forces on a galactic scale. Primordial black holes, with their potential to reveal secrets of the early universe, invite us to ponder the very origins of cosmic structure. The gravitational pull of black holes is a force to be reckoned with, shaping the orbits of nearby stars and the gas that spirals into their depths. As matter approaches a black hole, it forms an accretion disk, a swirling mass of energy and particles. This disk, glowing brightly as it heats up due to friction, can outshine entire galaxies. Imagine witnessing a cosmic whirlpool where gas and dust spiral inward, caught in an unstoppable gravitational embrace. The dynamics of this process are a beautiful interplay of physics, illustrating the delicate balance between gravitational attraction and the energy of infalling matter. The immense gravity of black holes also leads to fascinating phenomena known as gravitational lensing. When light from a distant star passes near a black hole, the gravitational field bends the light, creating a distorted image. This effect not only enhances our understanding of how light behaves in extreme conditions, but also allows astronomers to observe objects that would otherwise remain hidden beyond the dark veil of space. Picture this: a distant galaxy, its light stretched and warped, revealing secrets about its structure and composition. The universe, it seems, is a master artist, painting with light and gravity, crafting illusions that challenge our perceptions. Further, black holes provide a unique opportunity to test the limits of our understanding of physics. The concept of singularities, points of infinite density, where the laws of physics break down, forces us to confront questions about the very nature of reality. What happens at the core of a black hole? Can our current theories coexist with the phenomena observed in such extreme environments? The quest for answers drives scientists to probe deeper into the nature of spacetime itself. Renowned physicist Kip Thorne articulated this journey by stating, "The universe is a vast, complex place, and our understanding of it is still very much in its infancy." This acknowledgement of our limitations invites us to embrace curiosity as we venture into the unknown. As researchers employ advanced technologies, such as gravitational wave detectors and powerful telescopes, we inch closer to unraveling the mysteries hidden within black holes. Their elusive nature challenges us to think beyond conventional boundaries, urging us to explore the interplay between gravity and quantum mechanics. Consider the groundbreaking moment when gravitational waves were first detected. This event not only confirmed a key prediction of Einstein's theory of general relativity, but also opened a new window into the universe, allowing us to observe black holes merging across unimaginable distances. The resulting ripples in space-time provide us with invaluable information about these cosmic giants, illuminating their properties and behaviors. Imagine feeling the vibrations of the cosmos echoing through the fabric of space, a reminder that even the most distant events can resonate with our understanding of the universe. As we marvel at these discoveries, we cannot ignore the philosophical implications of black holes. They challenge our notions of time, space, and causality. The idea that information may be lost when it crosses the event horizon raises profound questions about the nature of reality. Can information truly disappear, or is it transformed in ways we have yet to comprehend? These queries push us to the edge of our understanding, inspiring explorations that weave together the realms of science and philosophy. In contemplating black holes, we also find ourselves reflecting on their place within the broader narrative of existence. They remind us of the transient nature of life and the cycles that define the universe. Stars are born, live, and die, often culminating in a spectacular collapse that gives rise to the very black holes we seek to understand. This cycle of creation and destruction echoes through the cosmos, illustrating the interconnectedness of all things. As we gaze into the night sky, we might ponder the fate of our own sun. In a few billion years, it will exhaust its nuclear fuel, expanding into a red giant before collapsing into a white dwarf. While it will not become a black hole, the remnants of its existence will contribute to the cosmic cycle, enriching the interstellar medium with the elements needed for new stars and planets to form. This cosmic ballet underscores the idea that black holes are not merely endpoints, but vital components of an ongoing process, influencing the birth and evolution of galaxies. They serve as markers of cosmic history, allowing us to trace the lineage of stars and the formation of structures across time. As we continue to explore the mysteries of black holes, we are reminded of the words of physicist Richard Feynman, who said, "The most important thing is not to stop questioning." Each question we ask opens new avenues for discovery, drawing us closer to understanding the intricate web of connections that define our universe. So, as you lay beneath the vast expanse of stars, consider the black holes that lurk in the depths of space. What secrets do they hold? What stories might they tell us about the universe's past and future? In the silence of the cosmos, they whisper of beginnings and endings, of creation and collapse, inviting us to journey further into the heart of cosmic mystery. Chapter 2: Theoretical Foundations, Physics Inside a Black Hole. As we turn our focus to the theoretical foundations that underpin the nature of black holes, we find ourselves at the intersection of two monumental theories: general relativity and quantum mechanics. Each theory offers a unique lens through which to view the universe, but together, they present a more complete picture of the extraordinary phenomena that lie within and beyond the event horizon of a black hole. General relativity, proposed by Einstein, reshaped our understanding of gravity. It posits that massive objects like stars and planets warp the fabric of spacetime itself. Imagine a vast, elastic sheet with heavy balls placed upon it, causing dips and curves. This curvature is what we perceive as gravity. In the vicinity of a black hole, this warping becomes extreme, creating a region where the gravitational pull is so intense that escape becomes impossible. The concept of spacetime merging with gravity leads to the conclusion that, at the center of a black hole, lies a singularity. A singularity represents a point of infinite density, where the laws of physics as we know them cease to apply. It is here that our understanding falters, as time and space intertwine in ways that challenge our very comprehension. The singularity is surrounded by the event horizon, the boundary beyond which all information is lost to the outside universe. This paradoxical nature evokes a sense of wonder and dread. What lies beyond that horizon? Can anything exist, or even be defined in such a realm? On the other hand, quantum mechanics introduces a world governed by uncertainty and probability. At the smallest scales, particles behave in ways that defy intuition. Consider the idea that particles can exist in multiple states simultaneously until observed. This concept stands in stark contrast to the determinism of classical physics. The challenge arises when trying to reconcile these two powerful frameworks. How does one describe the singularity of a black hole, where general relativity reigns supreme, while also considering the probabilistic nature of quantum mechanics? One might wonder, is it possible to unify these two theories into a single framework? Great minds like Stephen Hawking have dedicated their lives to this quest. Hawking's work on black hole thermodynamics revealed that black holes are not merely voids of nothingness, but emit radiation, now known as Hawking radiation. This groundbreaking insight suggested that black holes could eventually evaporate over immense timescales, bridging concepts from quantum theory with the gravitational pull of black holes. Imagine a black hole slowly losing mass and energy, defying the notion of permanence long associated with these cosmic giants. As we ponder the implications of these theories, we encounter the phenomenon of time dilation. Near a black hole, time does not flow at the same rate as it does elsewhere in the universe. According to general relativity, the stronger the gravitational field, the slower time appears to pass. This is not merely a theoretical abstraction, but has practical implications. Picture a spaceship approaching the event horizon of a black hole. To an observer on that ship, time would continue as normal. Yet, to someone watching from a safe distance, the events aboard the ship would appear to slow down, stretching into infinity. What would it feel like to experience such a divergence in time? This leads us to the gravitational effects that manifest near these enigmatic objects. As one approaches a black hole, tidal forces become pronounced. The immense difference in gravitational pull between the side closest to the black hole and the side furthest away results in what is known as spaghettification. Imagine being stretched like a strand of spaghetti, an experience that vividly illustrates the power of gravitational forces at play. This concept challenges our understanding of matter and the very structure of physical beings. How does one even begin to comprehend such an extreme experience? Despite the allure of these theories, the challenges in studying black hole physics are formidable. Black holes are inherently invisible. They do not emit light, making direct observation elusive. Scientists rely on indirect methods to infer their presence, such as observing stars orbiting an invisible mass or detecting the radiation emitted as matter is consumed by a black hole. These methodologies require ingenious ingenuity and cutting-edge technology. The Event Horizon Telescope, for instance, has made headlines by capturing the first image of a black hole's shadow, a bold leap into the unknown. This achievement was not merely a triumph of technology, but a testament to human curiosity and perseverance. How does one gather the collective efforts of scientists across the globe to accomplish such a feat? It speaks to the innate desire to uncover the mysteries of the universe, to shed light on the darkest corners of existence. As we navigate the complex landscape of black hole physics, we must also grapple with the philosophical implications of these celestial entities. What does it mean for our understanding of reality if black holes hold secrets that challenge the very foundations of physics? Can we reconcile the deterministic universe of classical physics with the unpredictable nature of quantum mechanics? These questions linger in the minds of physicists and philosophers alike, inviting us to reflect on the nature of knowledge itself. The study of black holes pushes the boundaries of human thought, urging us to confront the limits of our understanding. Each revelation invites us to reconsider what we know and inspires us to explore further. The quest to understand black holes, with their rich tapestry of theories and paradoxes, is a journey into the heart of the universe, a journey that beckons us to dream, question, and seek answers to the most profound mysteries that lie beyond our reach. The interplay between general relativity and quantum mechanics leads us to ponder the very nature of information itself in the context of black holes. A fundamental question arises: what happens to the information of matter that crosses the event horizon? This dilemma, often referred to as the information paradox, challenges our understanding of reality and the laws of physics. Imagine a scenario where a book is tossed into a black hole. The pages filled with knowledge and stories seem to vanish, lost forever. Yet, according to quantum mechanics, information cannot simply disappear. How can we reconcile these seemingly contradictory principles? Physicist Juan Maldacena proposed a groundbreaking idea known as the holographic principle, suggesting that all the information contained within a volume of space can be represented as a theory on its boundary. This concept implies that the three-dimensional world we experience might be an illusion, a projection of information stored on a two-dimensional surface. Envision this as a cosmic movie screen, where the events unfolding before our eyes are mere shadows of a deeper reality. Such perspectives compel us to reconsider our notions of existence and the very essence of what it means to know something. As we explore the gravitational effects near black holes, we also encounter the concept of gravitational waves, ripples in spacetime created by the acceleration of massive objects. When two black holes collide, they emit gravitational waves that travel across the universe, carrying with them invaluable information about their origins and characteristics. The detection of these waves has opened a new window into the cosmos, allowing us to observe cosmic events that were once beyond our reach. Picture the universe as a vast ocean, with these waves serving as messages from the depths, revealing secrets of celestial bodies that have long eluded us. The first detection of gravitational waves by LIGO marked a monumental achievement in physics. It was a moment when theory transformed into tangible evidence, confirming predictions made decades earlier. Scientists celebrated this triumph, recognizing that they had tapped into a new realm of exploration, one where black holes could no longer hide in the shadows. What might we learn from future encounters with these gravitational ripples? Each wave carries a story, inviting us to listen closely to the symphony of the universe unfolding around us. Yet, while these discoveries illuminate parts of the black hole narrative, significant challenges remain. The extreme environments near black holes defy our current technological capabilities for observation and experimentation. For instance, the conditions surrounding a black hole are so intense that any matter falling into its grasp is subjected to immense heat and pressure. This leads to the emission of high-energy radiation, creating an environment that is both hostile and fascinating. Scientists strive to understand how matter behaves under such conditions, raising questions about the fundamental building blocks of reality. What new physics might emerge from the study of particles in these extreme environments? The quest for understanding black holes also brings forth the notion of cosmic censorship, a hypothesis suggesting that singularities are hidden from the universe. This idea implies that the universe is designed in such a way that we are shielded from the chaotic nature of singularities, maintaining a semblance of order. Yet, even as we explore this hypothesis, we cannot help but wonder, what lies beyond the veil of cosmic censorship? Are there phenomena that exist outside our current models, waiting to be uncovered? Additionally, the search for answers extends beyond black holes themselves to the fabric of spacetime. The study of black holes compels us to consider the nature of spacetime itself. What if spacetime is not merely a stage for cosmic events, but an active participant in the unfolding drama of the universe? Some theorists are investigating the possibility that spacetime may have emergent properties, arising from more fundamental entities. This perspective invites us to imagine a universe where the very essence of existence is woven from intricate interactions at the quantum level. In contemplating these profound ideas, we are drawn to the figures who have shaped our understanding of black holes. Among them, Roger Penrose stands out, renowned for his work on singularities and their implications for the universe. His explorations have led to the development of the Penrose process, a theoretical mechanism by which energy can be extracted from a rotating black hole. This concept challenges our traditional views of energy conservation and opens up discussions about the potential for harnessing energy from these cosmic giants. Imagine a future where we might tap into the power of black holes, a notion once relegated to the realm of science fiction, now becoming a tantalizing possibility. As we continue our journey through the theoretical foundations that govern black holes, we are reminded of the beauty that lies within the mysteries of the cosmos. The pursuit of knowledge is a journey laden with obstacles and uncertainties, yet it is precisely these challenges that fuel our curiosity and drive us to explore further. Each question we ask and every theory we contemplate serves as a stepping stone toward greater understanding. The exploration of black holes is not merely a scientific endeavor. It resonates with our deeper human desire to uncover the unknown. As we contemplate the vastness of the universe, we are compelled to ask ourselves, what does it mean to exist in a cosmos filled with such wonders? The answers may elude us for now, but the journey itself is rich with discovery, urging us to continue seeking the truths that lie hidden in the darkness of black holes. In this quest, we are united by a shared curiosity, a collective heartbeat echoing through the corridors of time and space. The unfolding story of black holes is a testament to our resilience and insatiable thirst for understanding, a narrative that continues to weave itself into the fabric of human thought. As we delve deeper into this cosmic enigma, we remain ever hopeful that each revelation will bring us closer to the heart of the universe's mysteries. Chapter 3: Imagining Life Inside a Black Hole. As we venture into the heart of a black hole, we find ourselves grappling with the very essence of space and time. Imagine an immense void, where the familiar rules of physics unravel and reality bends in ways that challenge our comprehension. In this extraordinary realm, the fabric of space-time is stretched and contorted, creating a profound environment unlike anything we experience in our everyday lives. Within a black hole, time itself behaves in a peculiar manner. To an outside observer, an object falling into a black hole appears to slow down as it approaches the event horizon, the point of no return. Light emitted from this object becomes increasingly redshifted, fading into darkness, while for the object itself, time continues at its own pace. This is a striking illustration of how time is not a universal constant, but rather a malleable entity, shaped by gravity's pull. Now, consider the nature of light within this enigmatic space. Once it crosses the event horizon, light is trapped, unable to escape the overwhelming gravitational forces. It transforms the environment into a shadowy abyss, devoid of the illumination that typically guides our perceptions. In this dark expanse, how might life, if it could exist, adapt to such extreme conditions? The gravity inside a black hole is not merely powerful, it is transformative. Imagine a landscape where the force of gravity is so intense that it alters the fundamental structure of matter. In this hypothetical environment, life forms would need to evolve extraordinary adaptations to survive. Some scientists speculate that beings could exist in forms foreign to our understanding, perhaps resembling gelatinous entities that can withstand crushing pressures. These life forms might thrive in a world where density and pressure reach unimaginable levels, stretching the definition of life itself. Envision creatures that could manipulate the very fabric of space-time. They might possess an innate ability to bend their physical forms, allowing them to navigate through the gravitational maze of a black hole. The concept of such beings challenges our notions of biology and consciousness. How would they perceive their surroundings? Theories surrounding consciousness in the extreme conditions of a black hole open a window into profound philosophical questions. Could consciousness itself be a product of the environment? Some theorists propose that in extreme gravitational fields, consciousness might manifest differently, perhaps blending with the very fabric of space-time. Imagine a state of being where perception transcends the limitations of individual experience, allowing for a collective awareness among life forms. As we ponder these possibilities, we remember the insights of thinkers who have shaped our understanding of the universe. Theoretical physicist Roger Penrose has ventured into the realm of consciousness, suggesting that it might be linked to the quantum processes that occur in the brain. In a black hole, where the interplay of quantum mechanics and gravity becomes critical, could consciousness evolve in ways we cannot yet fathom? It invites us to reflect on the essence of what it means to be aware. In the depths of a black hole, the concept of time could fundamentally shift. For a being adapted to such an environment, time might not be linear as we perceive it, but could instead spiral or loop in on itself. This leads to fascinating questions. Would memories form in a way that is distinctly different from our own? Would experiences be layered in a manner that transcends the sequential flow of time? If we imagine life existing in such an environment, we must also consider the mechanisms through which these beings would sense their surroundings. Light, as we know it, would not provide the familiar avenues of perception. Instead, they might rely on other forms of energy or vibrations to navigate their reality. Perhaps they could sense gravitational waves, the ripples in space-time caused by massive objects, allowing them to interact with the universe in a way that is entirely alien to us. Consider the implications of this heightened sensitivity. Life forms could experience the universe as a symphony of gravitational harmonies, perceiving the movements of celestial bodies and the ebb and flow of cosmic energy. Their consciousness might expand to encompass a broader understanding of existence, blurring the lines between self and the cosmos. As we explore these hypothetical beings, we are reminded of the vastness of possibility within the universe. The vast majority of life we know is bound by the constraints of Earth, yet the realms beyond our planet may harbor forms of existence that challenge our very understanding of biology and consciousness. In contemplating life inside a black hole, we are confronted with the extraordinary nature of adaptation. Life, as we know it, thrives in a delicate balance of conditions. Yet, in the extreme environment of a black hole, we can imagine adaptations that are far removed from the familiar. Perhaps these beings would develop a form of photosynthesis not reliant on sunlight, but rather on the energy extracted from the gravitational forces surrounding them. Such adaptations would not only speak to the resilience of life, but also to the creative forces of evolution. Just as extremophiles on Earth have adapted to survive in the most hostile environments, like the boiling waters of deep-sea vents or the frigid deserts, life within a black hole might reveal the astounding potential of biological innovation. What would it mean for these beings to possess a sense of identity? In the absence of light and conventional time, self-awareness might manifest differently. Perhaps they would perceive themselves as interconnected threads within a larger cosmic web, their identities woven into the very structure of space-time. This perspective could enrich their understanding of purpose and existence, leading to a sense of unity with the universe that transcends individuality. As we immerse ourselves in these reflections, we are reminded of the words of Carl Sagan, who said, "The cosmos is within us. We are made of star stuff." This sentiment resonates even within the enigmatic confines of a black hole. If life could emerge in such an environment, it would still echo the elemental connections we share with the universe. In the midst of this cosmic exploration, we may find ourselves contemplating the very nature of existence. The boundaries of life, consciousness, and reality blur in ways that invite us to think beyond our earthly experiences. Are we merely observers of the cosmos, or are we also participants in a grander narrative? As we venture deeper into the mysteries of black holes, we become acutely aware of the limitations of our current understanding. The intersection of science and philosophy invites us to explore the unknown and consider the infinite possibilities that lie ahead. In this journey, we remain open to the wonder and awe that the universe presents, encouraging us to continue questioning and exploring the depths of existence. In the stillness of thought, we find ourselves pondering the paradoxes of life within a black hole. The very idea of existence in such an extreme environment evokes a sense of curiosity and humility. What if, within the darkest corners of the universe, life finds a way to thrive, defying our understanding of survival? As we embrace this contemplation, we are transported into a realm where the boundaries of science and imagination intertwine. Within a black hole, the possibilities are as boundless as the cosmos itself, inviting us to dream of the unimaginable and to celebrate the mysteries that lie beyond the stars. As we further immerse ourselves in the depths of a black hole, the interplay of gravity and light becomes ever more intriguing. The event horizon, where gravity's grasp becomes absolute, marks not just a boundary but a transformative threshold. Beyond this point, the familiar laws of physics dissolve into a realm where the ordinary ceases to exist. Within this dark domain, we can imagine environments shaped by the relentless force of gravity, where even the concept of solid ground may be rendered meaningless. Visualize a world where the very matter that composes life is stretched and compressed, twisted into new forms by the intense gravitational forces. Here, particles might exist in states beyond our current understanding, influenced by the extreme conditions that define their existence. In such an environment, the traditional building blocks of life may give way to entirely novel structures, perhaps even allowing for the emergence of life forms that thrive on the energy generated by gravitational interactions rather than light. Could these beings, thriving in the cold darkness, possess bioluminescent properties? Imagining life forms that utilize the faintest glimmers of energy, akin to the bioluminescent creatures of Earth's deep oceans, leads us to ponder how they might communicate or interact in a lightless world. Perhaps they would emit pulses of energy, creating a rhythmic exchange reminiscent of a heartbeat, allowing them to perceive and be perceived within the vast shadow. In this context, we might also consider how these life forms adapt their perception of reality. Without light as a reference, their senses could evolve to detect gravitational waves, the ripples created by the movement of celestial bodies. This heightened sensitivity would transform their perception, enabling them to navigate their surroundings through the symphony of gravitational forces that permeate the black hole. How might this ability influence their social structures, communication, and even their culture? The adaptations we envision draw parallels to the extremophiles found on our own planet. These organisms, resilient and resourceful, have evolved to thrive in environments previously thought inhospitable, boiling hot springs, acidic lakes, and even the frozen tundra. Just as they have adapted to their unique niches, so too might life inside a black hole develop extraordinary capabilities. At the heart of these considerations lies the question of consciousness. What does it mean to be aware in an environment where time is distorted and perception is fundamentally altered? We might imagine that consciousness within a black hole could be a fluid experience, unbound by the linearity that governs our understanding. Could it be that awareness itself becomes a dynamic interplay of energies and forces, a collective consciousness resonating with the fundamental aspects of the universe? As we ponder these ideas, we recall the thoughts of pioneers in the field of consciousness studies, who have pointed to the interconnectedness of all things. Might life inside a black hole embody this interconnected spirit, where individual experience merges into a collective awareness, transcending the limitations of solitary existence? This notion invites us to reflect on the broader implications of existence itself. If consciousness can adapt to extreme environments, what does that signify for our understanding of life beyond Earth? Are we not merely observers of the cosmos, but participants in a much grander narrative that encompasses all forms of existence? The very fabric of reality within a black hole invites us to question the boundaries of our understanding. With each hypothetical life form we envision, we peel back layers of mystery, revealing potential pathways of evolution and adaptation. In this exploration, we must also consider the nature of time itself within a black hole. For beings adapted to such an environment, time could spiral or oscillate, presenting experiences that defy our conventional definitions. Would memories be formed as snapshots, or perhaps as a continuous flow, allowing for an experience of existence that is altogether different from our own? This reimagining of time leads us to consider how relationships might evolve in such a context. If life forms within a black hole perceive time differently, how would their bonds and interactions reflect this unique understanding? Would they form connections that transcend individual moments, weaving their experiences into a shared tapestry of existence? The possibilities are vast and profound, urging us to expand our understanding of life and consciousness. Just as the cosmos invites us to look beyond the stars, so too does the prospect of life inside a black hole challenge us to explore the very nature of being. As we delve into these reflections, we find ourselves in a realm where science and imagination coalesce. The questions we ask may never fully be answered, yet they enrich our journey through the universe, inviting us to embrace the mysteries that lie beyond our grasp. In this contemplation, we recognize the beauty of the unknown, the wonder of existence, and the infinite possibilities that await us. What lies beyond the event horizon? Perhaps it is a world where life, in forms we cannot yet envision, thrives in the shadows of the universe, reminding us of the resilience of consciousness and the boundless nature of reality itself. As we linger in these thoughts, we are encouraged to maintain an open heart and mind, welcoming the extraordinary potential that existence presents. With every question, we cultivate a deeper understanding of our place within the cosmos and the mysteries that beckon us to explore further. Chapter 4: Exploring Event Horizons, What Lies Beyond? As we contemplate the mysteries of black holes, we arrive at a profound boundary known as the event horizon. This one-way barrier, shrouded in darkness, beckons us to ponder what lies beyond. When we approach the event horizon, we encounter a realm where the gravitational forces are so powerful that nothing can escape its grasp. Here, the very nature of reality begins to warp, and our conventional understanding of time and space fades into obscurity. Imagine standing at the edge of this vast abyss, gazing into the void. What would it feel like to be on the precipice of such a phenomenon? The event horizon represents the ultimate point of no return, where the escape velocity exceeds the speed of light. This astonishing fact leads to a question that has intrigued scientists for generations. What happens once something crosses this threshold? The concept of the event horizon raises tantalizing possibilities, especially when we consider insights from the holographic principle. This theoretical perspective suggests that all the information contained within a volume of space can be represented as a two-dimensional surface, existing at the boundary of that space. Imagine, if you will, that the entire universe is akin to a grand projection, where the three-dimensional experiences we perceive are mere shadows of information encoded on this two-dimensional surface. This principle finds its roots in the study of black holes, where the event horizon becomes a critical focal point. The mathematical underpinnings reveal that as matter falls into a black hole, the information about that matter does not simply vanish. Instead, it is theorized to be imprinted on the event horizon, forever altering our understanding of reality. The implications of this idea are profound, as they suggest that the universe is a tapestry woven from the threads of information, stretching across dimensions we have yet to fully comprehend. Yet this leads us to a perplexing dilemma known as the information paradox. If information is preserved on the event horizon, what happens to it when black holes evaporate, as predicted by Stephen Hawking's theory of black hole radiation. The idea that black holes could emit radiation implies they might eventually shrink and vanish, leaving behind an enigma. Where does the information go? Is it obliterated, as some theories suggest, or does it somehow escape into a different form? The very nature of information in the universe becomes a swirling mystery, challenging our grasp on reality itself. As we ponder the fate of information, we find ourselves at the intersection of science and philosophy, where questions abound. What if, instead of a singular universe, there exists a multitude of alternate realities or universes? This notion, often referred to as the multiverse theory, suggests that each decision we make or event that occurs could spawn a new universe, diverging from the original timeline. Imagine the vastness of possibilities, where every potential outcome manifests in its own reality, each existing parallel to our own. The concept of alternate realities invites us to explore the implications of such a multiverse. If our universe is but one of countless others, how do we perceive our existence? Are we merely travelers in a larger cosmic narrative, one that unfolds in ways we cannot yet fathom? As we explore these ideas, we find ourselves drawn to the words of the physicist David Deutsch, who eloquently stated that the multiverse is a reality that we must confront, not a mere fanciful idea. This perspective encourages us to embrace the unknown, to seek connections beyond the confines of our singular experience. Imagine standing at the event horizon, contemplating the myriad of worlds that might exist beyond. Each universe, a unique expression of reality, shaped by the choices and events that define it. What stories might unfold in these alternate realms? What life forms might emerge, guided by different physical laws or histories? As we navigate through these tantalizing ideas, we are reminded of the beauty of curiosity. The vastness of the cosmos offers us a canvas upon which we can paint our dreams, our fears, and our aspirations. Black holes and their event horizons serve as portals to the unknown, inviting us to question the very fabric of existence. In this exploration, we encounter not just the science of black holes, but the essence of human experience. The quest for knowledge and understanding transcends the boundaries of space and time, echoing through the ages. It is a journey that unites us all as we seek to unravel the mysteries of the universe, pushing the limits of our imagination. What lies beyond the event horizon may forever elude our grasp, yet the very act of questioning is what ignites the flame of discovery. As we peer into the darkness, we find not only a barrier, but an invitation to explore the profound depths of existence and to embrace the uncertainty that comes with it. With each thought, we are reminded that the universe is a place of wonder, where every question leads to new insights, and every insight opens the door to further exploration. As we venture forth, we remain ever curious, ever willing to seek the truths that lie beyond the veil of the known. At the heart of our inquiry into the event horizon lies the profound concept of the holographic principle. This idea posits that the universe we perceive is not merely a three-dimensional reality, but rather an intricate projection derived from two-dimensional information stored at the boundaries of space. Picture this boundary as a shimmering screen, a cosmic film upon which the drama of existence is played out. To grasp the implications of this idea, consider the implications of information itself. If all the information about the matter that falls into a black hole is encoded on its event horizon, it raises fascinating questions about the nature of reality. What if our understanding of space and time is merely a reflection of a deeper, more fundamental structure? The very act of observation, it seems, may be intertwined with the fabric of the universe itself. The holographic principle challenges our perception, suggesting that what we experience as solidity and presence may be an illusion, a complex interplay of information rendered into our consciousness. In a sense, it invites us to think of ourselves as both creators and observers within this grand narrative, where each thought and action contributes to the unfolding story of the cosmos. As we explore these ideas, we encounter the work of physicists like Juan Maldacena, who has significantly contributed to the development of the holographic principle. His insights illuminate the connection between gravity and quantum mechanics, bridging two realms of physics that often seem disparate. Imagine the elegance of a theory that suggests the universe is not just a collection of particles and forces, but a seamless interplay of information, transcending our traditional understanding of reality. Yet, this brings us back to the enigma of the information paradox. If information is encoded on the event horizon, what does it mean when a black hole evaporates? In the face of such a phenomenon, the notion of information loss becomes a source of contention among physicists. Some argue that once inside a black hole, information is irretrievably lost to the universe, while others propose that it could be released in a different form as the black hole fades away. This debate raises profound philosophical questions. Is information truly lost, or does it merely transform, shifting into a different state that we cannot yet comprehend? The implications reach beyond the realm of physics, beckoning us to consider our understanding of existence itself. What does it mean to exist if information can be erased? As we ponder these weighty matters, the very idea of alternate realities or universes begins to take shape. If the universe is indeed a vast multiverse, every decision and event could create a branching path, leading to realities that diverge from our own. Imagine standing at a cosmic crossroads, where each choice gives rise to a new universe, each with its own unique narrative. This concept not only expands our understanding of existence, but also enriches our appreciation for the choices we make. Each moment we experience could be a pebble cast into a pond, sending ripples outward across countless dimensions. What if the lives we lead in this universe are merely one thread in an expansive fabric of existence, interwoven with the stories of countless alternate selves? The echoes of this multiverse theory resonate through the works of thinkers like Max Tegmark, who encourages us to embrace the idea that reality is far richer than we might imagine. He suggests that every possible outcome exists in its own universe, a notion that compels us to reflect on the nature of choice and consequence. As we stand on the edge of the event horizon, we are invited to consider the vastness of possibilities that lie before us. Each alternate universe, a potential reflection of our own, shaped by the choices and paths taken or not taken. What if our dreams, our hopes, and even our fears are merely glimpses into the infinite possibilities that surround us? In this cosmic contemplation, we are reminded of the beauty inherent in uncertainty. The mysteries of black holes and event horizons encourage us to embrace the unknown, to seek knowledge with an open heart and mind. Perhaps, at the core of our existence lies a fundamental truth, that the universe is a tapestry woven from the threads of possibility, where every question leads to further exploration. As we delve into the depths of these ideas, we discover a rich interplay between science and philosophy, a dance that transcends the boundaries of our understanding. The event horizon serves not only as a barrier, but as a portal, opening our minds to the vast mysteries that await beyond. In the dark embrace of the cosmos, we find both the beauty of knowledge and the thrill of the unknown, a reminder of our place within this grand narrative. What does all of this mean for our journey through existence? It suggests that our quest for understanding is not merely an academic pursuit, but a deeply human endeavor, one that connects us to the cosmos and to each other. As we ponder the nature of reality, we are drawn together in our shared curiosity, united by the ever-present urge to explore, to question, and to dream. Standing at the event horizon, the vastness of the universe unfolds before us, inviting us to step beyond the known and embrace the uncertainty that lies ahead. Each thought becomes a bridge to new possibilities, illuminating the path forward as we seek to unravel the profound mysteries of existence. What lies beyond may remain elusive, but in our exploration, we find not just answers, but a deeper connection to the universe and to the very essence of being. Chapter 5: Black Holes in Time Travel, Fact or Fiction? As we journey deeper into the cosmos, we encounter the striking intersection of black holes and the tantalizing possibility of time travel. Theoretical frameworks suggest that these mysterious entities, with their immense gravitational pulls, may offer pathways through the very fabric of space-time, creating questions that stir the imagination. Could black holes serve as portals to other times or places, bending the rules of reality as we know them? The idea of time travel has long captured the human imagination, inspiring countless stories and scientific inquiries. Central to this discussion are wormholes, theoretical constructs that act as shortcuts through space-time. Picture two distant points in the universe connected by a tunnel through the fabric of space-time, allowing for instantaneous travel between them. This concept stems from the equations of general relativity, which allow for such peculiar geometries to exist under certain conditions. The notion of wormholes, however, is not without its complexities. To traverse a wormhole, one must contend with the paradoxes of time travel. Imagine stepping into a wormhole and emerging in the past. Would it be possible to alter events that have already transpired, potentially creating a ripple effect through history? This leads us to the famous grandfather paradox, where one could inadvertently prevent their own existence by altering past events. Such riddles beg deeper questions about causality. If the future can influence the past, what does that mean for our understanding of time itself? Einstein and Rosen first proposed the idea of wormholes in the 1930s, presenting what is now known as the Einstein-Rosen bridge. Their work illustrated that the fabric of space-time could twist in unexpected ways, but this theory remained largely speculative. In the decades since, scientists like Kip Thorne have expanded upon these ideas, exploring the feasibility of stable wormholes. Thorne, a Nobel laureate, once said, "The only thing we know for certain about the universe is that it is full of surprises." This sentiment resonates profoundly as we delve into the unknown. Yet, for all the allure of wormholes and time travel, scientific skepticism remains a steadfast companion. While the mathematics of general relativity can accommodate these fantastical ideas, the physical reality of creating or sustaining a wormhole poses significant challenges. Theoretical constructs often require exotic matter with negative energy density to remain stable, a substance that has yet to be discovered. Without it, these cosmic shortcuts remain tantalizing but unattainable. Furthermore, the nature of black holes themselves adds layers of complexity to the discussion. The event horizon, the boundary beyond which nothing can escape, creates a one-way street that complicates any notion of returning from the past. When we peer into the depths of a black hole, we are confronted with a singularity, a point where our current understanding of physics breaks down. What lies beyond that point? Can time itself be redefined, or is it an immutable flow that cannot be reversed? Exploring these questions invites us to consider the very nature of time. What if time is not a linear progression, but rather a vast landscape where all moments coexist simultaneously? This perspective shifts our understanding from a sequential timeline to a more complex tapestry of existence, where the past, present, and future might intertwine in ways we have yet to comprehend. As we explore these theoretical frameworks, we must also acknowledge the challenges inherent in the scientific method. Many scientists approach the concept of time travel through black holes with caution, recognizing that while fascinating theories abound, empirical evidence remains elusive. The speculative nature of these ideas often leads to debates about their validity. Could we ever truly harness the power of a black hole for time travel, or are we merely chasing shadows in the vast expanse of space? The literary works of science fiction have often paved the way for scientific inquiry, providing imaginative frameworks that inspire researchers. Authors like H.G. Wells and Isaac Asimov have woven narratives that challenge our perceptions of time. Their stories invite us to ponder the implications of time travel, reflecting our hopes and fears about altering the past. Yet, as we draw from these creative wells, we must ground our understanding in scientific rigor, exploring the limits and possibilities of what black holes may offer. As we delve into the paradoxes of time travel, we cannot help but wonder how these concepts resonate with our understanding of existence. If we were to encounter a future where time travel is possible, what ethical considerations would arise? Would we have the right to change history, or would such actions unravel the very fabric of reality? In the realm of speculative theories, scientists have proposed various models that explore the potential of time travel. Some suggest that the universe may contain multiple timelines, allowing for alterations without catastrophic repercussions. Others theorize that time itself may be more malleable than we perceive, shaped by the gravitational forces of massive objects like black holes. Imagination and inquiry intertwine in these discussions as we ponder the implications of bending time and space. The quest for understanding draws us into the depths of our own existence, pushing the boundaries of knowledge. As we stand on the precipice of discovery, we are reminded of the words of physicist Stephen Hawking, who once mused, "Time travel is a one-way ticket to the past." The universe, in its infinite wisdom, continues to challenge us. Each question we pose leads to new inquiries, inviting us to explore the unknown. The alluring dance of black holes and time travel remains a testament to our ceaseless curiosity, urging us to seek answers in the cosmos. As we contemplate these ideas, we invite listeners to imagine the vast potential that lies within the mysteries of black holes. How do they reshape our understanding of time, existence, and the very nature of reality? In this cosmic exploration, we are reminded of our place within the universe. Our journey through the realms of black holes and the theoretical frameworks of time travel is more than a mere intellectual exercise. It is a reflection of our desire to understand the cosmos and our connection to it. The fabric of space and time, woven into the very essence of our being, invites us to ponder the possibilities that lie ahead. As we move forward, the questions we explore will continue to intertwine with the fabric of our understanding. The interplay of black holes and time travel is a testament to the mysteries that await us, urging us to venture further into the depths of the cosmos. What awaits us beyond the event horizon? What truths lie hidden within the shadows of these cosmic enigmas? As we consider the theoretical frameworks for time travel via black holes, we find ourselves drawn into the intricate weave of physics and imagination. The pursuit of understanding the cosmos often leads to the exploration of concepts that, while deeply rooted in scientific theory, stretch the boundaries of our comprehension. One such concept is the idea of traversable wormholes, which, unlike their conventional counterparts, may allow for travel between distant points in both space and time. Imagine a tunnel that connects two separate areas in the universe, a bridge that bends the very fabric of spacetime itself. This notion is not merely a flight of fancy. It arises from the equations of general relativity, suggesting that if such structures could exist, they would offer an extraordinary means to traverse vast distances in an instant. The implications of traversable wormholes extend far beyond mere travel. They challenge our perception of causality and the linear progression of time. The thought of stepping into a wormhole and arriving at a different moment in time ignites the imagination, but it also brings forth profound questions. If one could journey to the past, what consequences might arise? Would history remain unchanged, or would the act of observation itself alter the course of events? This dilemma introduces us to various paradoxes inherent in the concept of time travel. Consider the bootstrap paradox, where an object is sent back in time and eventually becomes the very object that precipitated its existence. This conundrum raises intriguing questions about the nature of causality. Can an event exist without a clear cause, or is every moment in time linked in a chain of consequence? Such paradoxes remind us that while the allure of time travel is captivating, it is fraught with complexities that challenge our understanding of reality. As we navigate these theoretical landscapes, we must also acknowledge the skepticism that often accompanies discussions of time travel. Renowned physicist Albert Einstein himself expressed reservations about the feasibility of such phenomena. His theories laid the groundwork for understanding the universe, yet they also highlighted the constraints imposed by the laws of physics. The scientific community, while open to exploration, remains cautious when it comes to claims of time travel. This skepticism is rooted in the fundamental principles that govern our universe. The energy requirements for creating and sustaining a traversable wormhole are staggering, potentially exceeding the capabilities of our current technology. Exotic matter, necessary for maintaining the stability of a wormhole, has yet to be discovered or produced. The pursuit of such discoveries invites a sense of wonder while grounding our aspirations in the tangible realities of science. Moreover, the intricate nature of black holes adds another layer of complexity to the conversation. The singularity at the center of a black hole represents a point where our understanding of physics falters, a boundary beyond which the laws of time and space, as we know them, cease to apply. When contemplating time travel, we must consider that crossing the event horizon may lead to experiences that defy all conventional understanding. As we ponder these cosmic mysteries, we are reminded of the overarching nature of time itself. Imagine time not as a straight line, but as a vast, interconnected web of moments, where the past, present, and future exist concurrently. This perspective encourages us to explore the potential for time to be more flexible than we perceive. The journey through these theoretical frameworks also invites us to reflect on the impact of time travel on our understanding of existence. If we could alter our past, how would that redefine our identities? Would the choices we make today be influenced by the knowledge of future possibilities? These reflections lead us to consider the ethical implications of time travel. What responsibilities would accompany the power to change history? The potential for unintended consequences looms large, prompting us to question whether humanity could handle such profound control over time and fate. Would our actions in the past ripple through the present and future, fundamentally altering the course of events? Speculative theories surrounding time travel often suggest the existence of multiple timelines or parallel universes, allowing for the possibility of alternate outcomes without catastrophic repercussions. This view posits that each decision creates a branching path, leading to countless realities that coexist simultaneously. In this scenario, time travel becomes a means of exploration rather than a tool for alteration. As we delve into these fascinating ideas, we are reminded of the deep-seated desire to understand our place in the cosmos. The intersection of black holes and time travel captures the imagination, offering a glimpse into the extraordinary potential that lies beyond our current understanding. In this quest for knowledge, we discover that the universe is a canvas of possibilities, where the blend of scientific inquiry and human curiosity fuels our exploration. Each question we ask propels us further into the unknown, inviting us to confront the mysteries of existence with open minds. As we contemplate the theoretical frameworks for time travel via black holes, we are reminded of the profound interconnectedness of all things. The exploration of these concepts transcends the boundaries of science, intertwining with our aspirations, fears, and hopes for the future. In this cosmic journey, we find not only the allure of the unknown, but also a deeper understanding of ourselves and our relationship with the universe. The possibilities inherent in black holes and time travel serve as a reminder of the wonders that await us in the cosmos. As we continue to unravel these mysteries, we are left with a sense of awe, contemplating the profound implications of what lies beyond our current grasp. The universe is a vast expanse of questions, urging us to seek answers and embrace the journey of discovery. Chapter 6: Black Holes and the Fate of the Universe. Black holes play a crucial role in the grand narrative of cosmic evolution. These enigmatic entities are not merely the endpoints of massive stars, they serve as pivotal players in the ongoing story of the universe. Imagine a swirling galaxy, where stars are born in vibrant nurseries, live out their luminous lives, and ultimately succumb to gravity's relentless embrace. This cycle is intricately woven with the presence of black holes, which act as both destroyers and creators in the cosmic theater. Theories abound regarding the role of black holes as cosmic recycling centers. Within the heart of their gravitational pull, matter is drawn in, crushed, and transformed. This process not only contributes to the growth of the black hole itself, but also influences the surrounding environment in profound ways. As stars and gas spiral into a black hole, they form what is known as an accretion disk. This disk is a swirling mass of material that heats up to incredible temperatures, emitting light across the spectrum, from radio waves to X-rays. This radiant energy can be detected by our telescopes, offering insights into the dynamics of these cosmic giants. Consider the notion that black holes might help fuel the formation of new stars. When material is consumed by a black hole, it doesn't simply vanish. Instead, it can be ejected back into space in powerful jets, traveling at nearly the speed of light. These jets can collide with surrounding interstellar gas, triggering shock waves that compress the gas and stimulate star formation. In this way, black holes may play an unexpected role in the continuous cycle of birth and death in the cosmos. What might this mean for the fate of the universe? The scenarios are as varied as they are fascinating. One possibility is a future characterized by a gradual cooling of the cosmos, leading to a state referred to as the heat death. In this scenario, galaxies drift apart, and stars exhaust their nuclear fuel, leaving behind only cold, dark remnants. As black holes continue to consume matter, they would eventually dominate the universe, their immense presence lingering as the last bastions of gravitational influence. Alternatively, some theories suggest that black holes could lead to a more dynamic end. The concept of black hole evaporation introduces the idea that black holes are not entirely eternal. According to this theory, they may lose mass over time through a process known as Hawking radiation, named after the brilliant physicist Stephen Hawking. This radiation arises from quantum effects near the event horizon, allowing black holes to emit tiny particles and gradually shrink. If this process continues indefinitely, one can envision a universe where black holes slowly evaporate, leaving behind nothing but a sea of radiation and empty space. Furthermore, there is the intriguing notion of black holes merging. As they consume surrounding matter and grow, they may eventually encounter one another, resulting in spectacular collisions. These events could produce gravitational waves, ripples in space-time that travel outward, forever changing the cosmic landscape. Imagine the energy released during such an event, a cosmic symphony reverberating through the universe, marking the end of one era and the beginning of another. The impact of black holes on galaxy formation and structure cannot be overstated. Supermassive black holes, residing at the centers of galaxies, exert a profound influence on the dynamics of their host galaxies. Their gravitational pull affects the orbits of stars and gas, shaping the very architecture of the galaxy itself. The relationship between a galaxy and its central black hole is symbiotic. As the black hole grows, it can stabilize the galaxy, preventing it from collapsing under its own weight. Prominent scientists have long contemplated the implications of black holes on galactic formation. The astrophysicist Andrea Ghez, in her groundbreaking work, has provided evidence of a supermassive black hole at the center of our own Milky Way galaxy. Her research not only substantiates the existence of these titanic entities, but also highlights their essential role in the formation and evolution of galaxies. Can you imagine the intricate dance of stars orbiting a black hole, their paths dictated by the invisible hand of gravity? The interplay between black holes and galaxy formation raises questions about the uniformity of the universe itself. How do these colossal structures influence the distribution of galaxies across the cosmic landscape? Observations suggest that galaxies with more massive central black holes tend to be larger and more massive themselves. This correlation hints at a profound relationship, one where the growth of a galaxy is intimately tied to the growth of its supermassive black hole. As we contemplate the fate of black holes, we are reminded of their dual nature as both creators and destroyers. They serve as cosmic recyclers, transforming the remnants of dying stars into radiant energy, while simultaneously shaping the structure and evolution of galaxies. The universe, in all its vastness, is a dynamic entity, and black holes are central to its narrative. In this intricate web of cosmic evolution, we can envision a future where black holes continue to exert their influence, guiding the very fabric of the universe. Perhaps they are not merely endpoints, but rather gateways to new beginnings. As we gaze into the night sky, we are reminded that black holes, in their silence and darkness, hold the keys to understanding the ultimate fate of the cosmos. What lies ahead in the cosmic journey? The answer may be hidden in the depths of black holes, waiting to be unveiled by future generations of explorers and thinkers. The universe, in its endless cycle of creation and destruction, invites us to ponder our place within it. Can we truly fathom the enormity of it all? The interplay between black holes and cosmic evolution may be one of the most profound mysteries still to be unraveled. As we drift through this cosmic landscape, let us embrace the wonder and complexity of black holes, for they are not just remnants of stars, but vital components of the universe's grand design. Each black hole is a testament to the intricate processes that govern the cosmos, a reminder of the delicate balance between creation and destruction that shapes our reality. The journey through the universe is far from over, and black holes remain at the heart of this unfolding story, inviting us to explore, question, and marvel at the wonders of existence. The role of black holes in cosmic evolution extends far beyond their immediate gravitational influence. They are thought to be instrumental in shaping the very characteristics of galaxies across the universe. Picture a universe teeming with galaxies, each uniquely sculpted by the forces of gravity and the presence of black holes at their cores. The gravitational well of a supermassive black hole can dictate the motion of stars, gas, and even dark matter within a galaxy, creating a delicate balance that sustains its structure and stability. As we observe galaxies through powerful telescopes, scientists have uncovered a striking correlation. Galaxies that are more massive often harbor supermassive black holes that are proportionally larger. This relationship suggests a profound interplay between the growth of galaxies and the evolution of their central black holes. Can you envision the dance between a galaxy and its black hole, as each influences the other's fate over cosmic timescales? This symbiosis might help explain why some galaxies are sprawling giants, while others remain smaller and more compact. Consider the idea that black holes might act as the engines of galaxy formation. When they consume matter from their surroundings, they not only grow but also expel energy in the form of jets and winds. These outflows can regulate star formation in their host galaxies. Imagine a black hole at the center of a galaxy, blasting out energy that compresses surrounding gas clouds, triggering the birth of new stars. This mechanism creates a feedback loop. As stars form, they enrich the surrounding medium with heavy elements, which in turn can fuel the growth of subsequent generations of stars. It is a continuous cycle, illustrating how black holes participate in the cosmic narrative of birth, death, and rebirth. The concept of cosmic recycling centers invites us to ponder the fate of black holes themselves. What happens to them as they age and consume vast amounts of matter? The life cycle of a black hole may not be a straightforward path toward eternal darkness. Some theories suggest that black holes may eventually merge with one another, creating even more massive entities. Envision the moment two black holes collide, generating ripples in space-time known as gravitational waves. This phenomenon not only reshapes the black holes involved, but also sends waves of energy cascading across the universe, a reminder of the dynamic nature of the cosmos. The collisions of black holes can also illuminate the past, revealing secrets about the early universe. By studying the gravitational waves emitted during such events, scientists gain insights into the properties of black holes and the environments in which they formed. It raises fascinating questions. How did these primordial black holes come into existence? Were they born from the remnants of the first stars, or do they have origins yet to be discovered? Each merger carries with it the potential for new understanding, a glimpse into the processes that shaped our universe from its infancy. As we contemplate the possible end scenarios involving black holes, we are drawn to the idea of the universe's ultimate fate. One intriguing possibility is the eventual dominance of black holes as the universe cools and galaxies drift apart. In this scenario, black holes may become the final remnants of a once vibrant cosmos, their gravitational pull lingering in the vast emptiness. Can you imagine a universe where black holes are the only witnesses to the history of stars and galaxies, their silent presence echoing the stories of creation and destruction? Moreover, the phenomenon of Hawking radiation introduces an alternative perspective on the longevity of black holes. Stephen Hawking's groundbreaking theory posits that black holes can emit radiation due to quantum effects near their event horizons. This radiation suggests that black holes are not truly eternal. Instead, they may slowly evaporate over unimaginable timescales. As they lose mass, they could eventually reach a point of complete dissolution, leaving behind a universe filled with the faint glow of radiation. This notion challenges our understanding of black holes as ultimate endpoints, inviting us to consider a more complex narrative of cosmic change. In contemplating the intricate relationships between black holes and the cosmos, we must also acknowledge the role of dark matter and dark energy in shaping the universe's structure. Dark matter, believed to comprise a significant portion of the universe's mass, influences the dynamics of galaxies and their interactions. Although invisible, the gravitational effects of dark matter can guide the formation of galaxies, intertwining with the influence of black holes. How does this unseen force interact with the luminous matter we observe? And what role do black holes play in this grand equation? As we delve deeper into these cosmic mysteries, we find ourselves at the intersection of observation and theory. The study of black holes not only reveals the nature of gravity and space-time, but also poses profound questions about the fundamental workings of the universe. Each revelation opens new avenues for exploration, challenging our understanding of existence itself. Imagine standing on the precipice of knowledge, gazing into the depths of black holes, where the known meets the unknown. The universe invites us to journey further into this enigmatic realm, where black holes are not mere shadows of destruction, but rather essential players in the cosmic drama. They remind us that even in darkness, there is the potential for light and transformation, a cycle that continues to unfold across the vast expanse of space. As we reflect on the impact of black holes on galaxy formation and the fate of the universe, we are drawn into a narrative that transcends time and space. They are not just cosmic phenomena, but symbols of our quest for understanding, urging us to explore the depths of existence and the mysteries that lie beyond. Each black hole is a doorway to the unknown, a chance to glimpse the beautiful complexity of the universe and our place within it. The journey through this cosmic landscape is far from over, and as we continue to explore, the stories of black holes will guide us toward new horizons of discovery and wonder. Chapter 7: Observing Black Holes, Techniques and Technologies. In the quest to observe black holes, scientists have developed a range of techniques that delve into the depths of the universe's most enigmatic phenomena. The two primary methods of detection revolve around gravitational waves and electromagnetic radiation. Gravitational waves, ripples in the fabric of space-time, were first predicted by Einstein's theory of general relativity. When two massive objects, such as black holes, collide, they send out these waves, which travel across the cosmos at the speed of light. Imagine the gentle vibrations of a still pond when a stone is thrown in, creating concentric ripples that expand outward. Similarly, gravitational waves carry information about their origins, allowing us to glimpse the violent dance of black holes merging. In recent years, the detection of these waves has transformed our understanding of the universe. LIGO, the Laser Interferometer Gravitational Wave Observatory, marked a monumental achievement when it first detected gravitational waves in 2015. This groundbreaking event opened a new window into astrophysics, enabling scientists to observe black holes not through light, but through the echoes of their collisions. "We have detected a cosmic cataclysm," exclaimed one of the researchers, capturing the essence of this remarkable discovery. Electromagnetic radiation, on the other hand, provides a more traditional avenue for observing black holes. This radiation encompasses all forms of light, from radio waves to gamma rays, allowing us to peer into the environment surrounding these cosmic giants. When matter spirals into a black hole, it forms an accretion disk, heating up and emitting intense radiation across various wavelengths. Picture a whirlpool where matter is drawn inward, spinning faster as it approaches the center. The friction and gravitational forces generate heat, leading to dazzling emissions of light that can be captured by telescopes. The Event Horizon Telescope represents a remarkable milestone in our pursuit of understanding black holes. This global network of radio telescopes was designed specifically to image the shadow of a black hole. In 2019, It produced the first-ever image of a black hole at the center of the galaxy M87, revealing a dark silhouette surrounded by a halo of glowing gas. Imagine gazing at a vast, swirling cosmic whirlpool, where the darkness represents the black hole, and the light surrounding it signifies the frenetic activity of matter being consumed. This stunning visual offered a tangible glimpse into a region once thought to exist solely in the realm of theoretical physics, bridging the gap between the abstract and the observable. The significance of this achievement extends beyond mere imagery. It provides insights into the behavior of matter and energy in extreme conditions, allowing scientists to test the predictions of general relativity. As the famous astrophysicist Kip Thorne remarked, the Event Horizon Telescope is a transformative instrument that will help us understand the universe and our place in it. Space missions and observatories around the globe have also played an integral role in advancing our understanding of black holes. Observatories like the Chandra X-ray Observatory and the Hubble Space Telescope have been pivotal in detecting X-ray emissions and other light from the regions surrounding black holes. These instruments allow us to explore the dynamics of accretion disks, jets of particles, and the interactions of black holes with their environments. Each observation enhances our comprehension of these phenomena, weaving together a narrative rich with cosmic detail. Consider the contributions from space missions, such as the European Space Agency's Gaia mission, which is charting the positions of stars in our galaxy with unprecedented precision. Gaia's data enables scientists to trace the movements of stars influenced by the gravitational pull of nearby black holes. This approach reveals the hidden presence of black holes that are otherwise undetectable, broadening our understanding of their distribution and impact within our galaxy. As we look to the future, the landscape of black hole exploration promises to evolve dramatically with emerging technologies. Instruments capable of detecting gravitational waves in a broader frequency range are being developed, allowing us to capture more events and glean deeper insights into the universe. Imagine a world where the cosmos speaks to us in a symphony of gravitational echoes, each note representing a collision or merger of black holes. Moreover, advancements in imaging technologies may lead to even sharper and more detailed pictures of black holes and their surroundings. The next generation of telescopes, such as the James Webb Space Telescope, is designed to capture infrared light, revealing the hidden structures of the cosmos that are obscured by dust. As we peer into these depths, we may uncover the formation of stars and galaxies influenced by black holes, illuminating the interconnectedness of the universe. Additionally, the concept of space-based observatories offers tantalizing possibilities. By positioning instruments beyond Earth's atmosphere, we can avoid the distortions caused by air and light pollution, leading to clearer observations of distant black holes. Imagine a future where we can observe the universe from the serene vantage point of space, unimpeded by terrestrial limitations, allowing us to focus our gaze on the wonders that lie beyond. In this exciting era of exploration, the boundaries of our knowledge expand with each discovery, inviting us to ponder the profound mysteries of black holes. What secrets might we unlock with the technologies of tomorrow? Each advancement brings us closer to unraveling the intricacies of these cosmic phenomena, expanding our understanding of the universe and our place within it. As we continue to refine our methods of observation, we are reminded of the words of the physicist Richard Feynman, who said, "The imagination of nature is far greater than the imagination of man." In the midst of this cosmic exploration, it remains essential to maintain a sense of wonder. Each black hole we observe is not merely a point of darkness in the universe. It is a testament to the incredible processes that govern the cosmos. The interplay of light and gravity, the dance of matter and energy, all culminate in these fascinating entities that challenge our perceptions and ignite our curiosity. As we stand on the brink of discovery, let us embrace the journey ahead, one filled with the promise of knowledge and understanding that beckons from the depths of space. The exploration of black holes is not solely confined to Earth-based observations. Space missions and observatories have significantly advanced our ability to gather information about these mysterious entities. The Chandra X-ray Observatory, launched by NASA, has provided a wealth of data by observing X-ray emissions from the regions surrounding black holes. The intense gravitational forces at play cause the matter in the accretion disks to heat to millions of degrees, emitting X-rays that can be detected by this powerful telescope. Picture a cosmic furnace, where matter is transformed into energy, illuminating the void with dazzling brilliance. This X-ray data allows scientists to study the behavior of matter in extreme conditions, lending insight into the dynamics at play in these fascinating environments. Another groundbreaking observatory, the Hubble Space Telescope, has captured stunning images of galaxies hosting supermassive black holes at their centers. By observing the motion of stars in the vicinity of these black holes, astronomers can infer their mass and the gravitational influence they exert. Imagine tracking the orbits of celestial bodies, each movement revealing secrets about the invisible forces that govern their paths. Hubble's contributions have not only enriched our understanding of black holes, but have also provided a context for their evolution within the larger structure of galaxies. The European Space Agency's Gaia mission is pioneering a new frontier in astrophysics by mapping the positions and movements of stars with unprecedented precision. This mission offers a unique perspective on black holes that are not actively consuming matter. By observing the gravitational effects these hidden giants have on nearby stars, Gaia illuminates the presence of black holes that might otherwise remain undetected. Each star's trajectory acts as a breadcrumb trail, leading us closer to understanding the unseen inhabitants of our galaxy. As we look toward the horizon of future technologies, the potential for deeper exploration becomes increasingly tantalizing. One of the most exciting prospects is the development of gravitational wave observatories that can detect a wider range of frequencies. This expansion would enable scientists to capture more events, unveiling a broader spectrum of black hole collisions and mergers. Imagine a celestial orchestra, each event producing harmonies that reverberate through space-time, allowing us to piece together the symphony of cosmic history. In addition to gravitational wave detection, the next generation of telescopes promises to enhance our understanding of black holes and their environments. The James Webb Space Telescope, with its advanced infrared capabilities, aims to uncover the hidden structures of the universe obscured by dust and gas. By revealing the formation of stars and galaxies influenced by black holes, Webb's observations may illuminate the intricate relationships within the cosmos. Imagine gazing into the depths of space and witnessing the birth of stars in the shadow of a black hole, where gravitational forces shape the very fabric of existence. Furthermore, the prospect of space-based observatories offers unparalleled opportunities for observing black holes. By positioning instruments beyond the reach of Earth's atmosphere, we can eliminate the distortions caused by air and light pollution. This unobstructed view allows for clearer observations of distant black holes, enabling us to focus on the complex phenomena surrounding them. Picture a serene vantage point in space, where the wonders of the universe unfold without the interference of our terrestrial environment, revealing truths that have long eluded our grasp. As we contemplate the future of black hole exploration, we are reminded of the unyielding curiosity that drives our pursuit of knowledge. Each technological advancement opens new doors, inviting us to ponder the mysteries that lie ahead. What revelations will emerge from the depths of space? How will our understanding evolve as we refine our observation techniques? These questions fuel the excitement of exploration as we stand on the brink of discovery. The journey to comprehend black holes is a testament to the collective efforts of researchers, engineers, and dreamers who have dedicated their lives to unraveling the cosmos's secrets. Every observation, every technological leap, is a step toward understanding not only the nature of black holes themselves, but also our place in the grand tapestry of the universe. As we venture forward, let us cherish this journey, knowing that the mysteries of black holes are not merely puzzles to solve, but profound reflections of the universe's intricate beauty. With each advancement in technology, we inch closer to answering the profound questions that have captivated humanity for generations. The captivating interplay of light and gravity, the swirling chaos surrounding these enigmatic entities, continues to inspire awe and wonder. As we navigate this cosmic journey, we are reminded that the universe is much more than a collection of stars and planets. It is a grand stage where the fundamental forces of nature play out in ways that challenge our understanding and ignite our imaginations. Each black hole we discover enriches our narrative, adding to the story of existence itself. Chapter 8: Cultural and Philosophical Implications of Black Holes. The allure of black holes extends far beyond the realm of physics, weaving its way into the fabric of literature and science fiction. For centuries, authors and storytellers have embraced the enigmatic nature of these cosmic giants, crafting narratives that explore the unknown. From the haunting depths of H.G. Wells' The Time Machine to the profound questions posed in Arthur C. Clarke's The City and the Stars, black holes have served as a compelling backdrop for contemplating existence and the cosmos. Imagine a world where the boundaries of reality blur, where characters grapple with the unknown, and where journeys through time and space are not just metaphors, but tangible experiences. In literature, black holes often symbolize the ultimate frontier, a gateway to profound transformations and existential revelations. They invite readers to ponder the implications of crossing thresholds, both literal and metaphorical. What might it feel like to teeter on the edge of such a vast abyss, where the known universe fades into darkness? Philosophers, too, have ventured into the realm of black holes, using them as catalysts for deep reflection on existence, reality, and the nature of knowledge itself. The questions they raise are both profound and unsettling. If the universe contains regions where the laws of physics cease to apply, what does that reveal about our understanding of reality? How do we reconcile the existence of something so seemingly absolute, yet so fundamentally incomprehensible? Consider the words of the philosopher and cosmologist, Brian Greene, who remarked that the universe is a symphony of strings, and the music of the cosmos plays out in the notes of black holes. This perspective invites us to visualize black holes not merely as destructive forces, but as integral components of the cosmic orchestra. They challenge us to rethink our place within the universe, compelling us to confront the very foundations of our existence. As we ponder the implications of black holes, we recognize their profound impact on our understanding of the universe. The existence of these extraordinary entities forces us to reconsider the boundaries of what we know, and more importantly, what we do not know. The concept of a black hole compels us to confront the limitations of human perception and comprehension. How can we grasp the nature of something that exists beyond the reach of light, a phenomenon that eludes our senses? This inquiry is not just an abstract exercise, it reverberates through the very core of human curiosity. The quest to understand black holes is a testament to our relentless desire to explore the unknown. Each discovery, every new piece of information about these cosmic enigmas, expands the horizons of human knowledge. It reminds us that the universe is a vast expanse filled with mysteries waiting to be unveiled. The metaphor of the black hole extends beyond the physical realm, infiltrating modern thought and cultural narratives. In many ways, it embodies the struggle against the unknown, representing the fears and uncertainties that accompany exploration. Black holes can symbolize the challenges we face in confronting our own limitations, evoking a sense of humility in the face of the cosmos. Consider the artist's depiction of a black hole as a swirling vortex, drawing everything into its depths. This imagery resonates with our fears of the unknown and the uncontrollable aspects of life. It reflects the chaos that often accompanies change and transformation. How often do we find ourselves standing at the precipice of a new experience, feeling the pull of the unknown? The black hole serves as a powerful metaphor for these moments of uncertainty, capturing the essence of our struggles to embrace change. The philosophical implications of black holes also extend to the nature of time itself. In the vicinity of a black hole, time behaves in ways that defy our conventional understanding. Imagine a clock ticking at a different pace as one approaches the event horizon, where time dilates and stretches like elastic. This phenomenon raises profound questions about the fabric of reality. If time is not a constant, how do we measure our experiences? What does it mean for our understanding of past, present, and future? Furthermore, the black hole embodies the paradox of knowledge. The more we learn, the more we realize how little we truly understand. This idea resonates deeply with the philosophical inquiry into the nature of existence. As we delve into the mysteries of black holes, we encounter the limits of human cognition, prompting us to reflect on what it means to know. Are we merely scratching the surface of a far greater reality, one that lies beyond our comprehension? Throughout history, thinkers have grappled with these questions. The physicist Stephen Hawking, renowned for his groundbreaking work on black holes, once stated, "The greatest enemy of knowledge is not ignorance, it is the illusion of knowledge." This perspective invites us to approach the mysteries of the universe with humility and curiosity. It encourages us to embrace the unknown, recognizing that the pursuit of knowledge is a journey fraught with uncertainties. As we continue to explore the cultural implications of black holes, we find that they have permeated popular culture, influencing films, art, and music. The haunting soundtracks of sci-fi films often echo the themes of cosmic exploration, while visual artists depict the mesmerizing beauty of the cosmos, capturing the essence of black holes in their work. Through these mediums, black holes become symbols of exploration and the human spirit's quest for understanding. Envision a film that portrays the journey of a space traveler venturing into a black hole. As the protagonist approaches the event horizon, the visuals become a kaleidoscope of colors and shapes, pulling the audience into a realm where the rules of reality dissolve. It compels viewers to confront their own fears of the unknown, inviting them to reflect on their relationship with the cosmos. In literature, the black hole serves as a poignant metaphor for the human experience. Characters who confront their fears or embark on transformative journeys often encounter their own black holes, moments of profound change that challenge their understanding of self and reality. These narratives resonate with our own experiences of growth and transformation, reminding us that the unknown can serve as a catalyst for personal evolution. The impact of black holes on human understanding of the universe is not merely an academic exercise. It is an integral part of our collective consciousness. As we seek to comprehend these cosmic entities, we find ourselves reflecting on our own existence, the nature of time, and the mysteries that linger just beyond our grasp. Each revelation about black holes serves as a mirror, reflecting our own struggles and aspirations as we navigate the complexities of life. As we immerse ourselves in the cultural and philosophical implications of black holes, we are reminded of the profound interconnectedness of science and the human experience. The mysteries of the universe resonate deeply within us, prompting questions that transcend the boundaries of knowledge. In this dance between understanding and uncertainty, we find the essence of what it means to be human, a continuous quest for meaning in the face of the unknown. Through the lens of black holes, we learn that the cosmos is not merely a backdrop for our existence, but a participant in the grand narrative of humanity. It challenges us to confront our fears, embrace the unknown, and seek deeper understanding. The black hole becomes a symbol of the ultimate journey, one that transcends the limits of space and time, inviting us to explore the very nature of reality itself. As we delve further into the cultural and philosophical implications of black holes, we can't help but recognize their profound representation in literature and art. Authors and artists alike have harnessed the mysterious allure of black holes to reflect not just on the cosmos, but on the human psyche. In the pages of novels, black holes often symbolize the ultimate confrontation with the unknown, a dark mirror reflecting our fears and desires. Consider the poignant narratives woven by writers such as Octavia Butler, whose works help us explore the intersection of humanity and the cosmos. In her stories, characters confront their own limitations, akin to standing before a black hole where the boundaries of existence blur. This imaginative leap invites readers to wrestle with challenging questions about identity, change, and the unknown. How often do we find ourselves on the brink of transformation, staring into our own metaphorical black holes? In the realm of visual art, black holes serve as a powerful motif that evokes both fascination and dread. Artists conjure images of swirling darkness and radiant light, capturing the tension between creation and destruction. The captivating work of contemporary artists often portrays black holes as gateways to other dimensions, reflecting humanity's ceaseless quest for exploration. The swirling forms and contrasting colors invite us to contemplate the vastness beyond our comprehension. What stories might these dark vortices tell if they could speak? Philosophically, the existence of black holes incites inquiries into the nature of reality and existence itself. They challenge the notion of a static universe, presenting instead a dynamic interplay of matter and energy. If black holes exist, what does that say about the very structure of space-time? Imagine a universe where the rules are not only different but also flexible, a realm where the concepts of past, present, and future intertwine in a cosmic dance. The implications of this fluidity extend to our understanding of consciousness. If we are part of a universe that includes black holes, what does that suggest about the nature of our thoughts and experiences? Are our perceptions simply reflections of a deeper reality, one that oscillates between the known and the unknown? Philosophers have long speculated on the relationship between consciousness and the cosmos, positing that our understanding of existence is shaped by the very fabric of the universe itself. Moreover, black holes provoke profound reflections on the nature of fate and free will. As we navigate our lives, we often encounter moments that feel predetermined, as if we are being drawn into a gravitational field beyond our control. This resonates with the concept of an event horizon, where choices fade into the unknown. Are we, like particles falling into a black hole, bound by the gravitational pull of our past decisions, or do we possess the agency to alter our trajectories? The metaphor of the black hole encapsulates the existential struggle inherent in the human experience. It evokes the tension between the desire for knowledge and the acceptance of uncertainty. Just as black holes remain elusive and enigmatic, so too do the answers to our most pressing questions about existence. This recognition can be both comforting and unsettling, reminding us that the journey of understanding is often fraught with ambiguity. As we reflect on the impact of black holes on our cultural narratives, we see how they embody the essence of exploration, the eternal quest for meaning in a universe that can feel overwhelmingly vast. They encourage us to push the boundaries of our imagination, inviting us to dream of possibilities that transcend our current understanding. Imagine standing on a distant world, gazing into the depths of a black hole. What might you discover? Would you find answers to the mysteries that have haunted humanity for generations? The allure of such questions propels us forward, fueling our insatiable curiosity about the cosmos. In contemplating the unknown, we find not just a reflection of the universe, but an exploration of our very selves. The dialogue between science and philosophy, illuminated by the presence of black holes, enriches our understanding of the universe and our place within it. As we continue this exploration, we are reminded that black holes are not merely cosmic phenomena. They are profound symbols of our shared human experience, beckoning us to confront our own uncertainties and embrace the journey of discovery. In this ever-expanding narrative, we find that black holes, with their consuming gravity and mysterious nature, challenge our perceptions of reality, urging us to carve new paths through the cosmos of thought. They remind us that even amidst the darkness, there is light to be found, whether in the form of knowledge, creativity, or the sheer wonder of existence itself. Chapter 9: Scientific Breakthroughs, Recent Discoveries and Theories. Recent advancements in black hole research have illuminated previously hidden corners of the universe, unveiling truths that challenge our understanding of these cosmic giants. Scientists are now able to observe black holes in ways that were once thought to be the stuff of science fiction. The dawn of gravitational wave astronomy has been a significant leap forward, allowing us to witness the dramatic events that occur during black hole mergers. These cataclysmic events send ripples through space-time, creating vibrations that we can detect with highly sensitive instruments. Imagine, if you will, the moment two black holes spiral toward each other, their immense gravitational forces tugging at the very fabric of the cosmos. As they collide, they release energy equivalent to that of millions of stars, a spectacle that resonates through the universe. One of the most profound discoveries in this realm is the realization that black holes are not solitary entities. They often exist in pairs, engaged in a gravitational dance that can culminate in their eventual merger. This process has significant implications for our understanding of cosmic evolution, as these mergers contribute to the growth of supermassive black holes lurking at the centers of galaxies. Each collision leaves behind a remnant, often more massive than its predecessors, perpetuating a cycle of cosmic evolution that has been ongoing since the universe began. The interpretation of these mergers extends beyond mere observation. The data collected from gravitational waves provides insights into the masses and spins of the black holes involved, leading to tantalizing questions about their formation and evolution. How did these black holes come to be? Are they remnants of ancient stars, or did they form through other processes entirely? Researchers are piecing together the puzzle, and with each new merger detected, we come closer to understanding the intricate history of these enigmatic objects. Artificial intelligence plays a crucial role in this journey of discovery. The sheer volume of data generated from gravitational wave observations is staggering, and sifting through it can be a monumental task. By employing advanced algorithms and machine learning techniques, scientists can analyze patterns within the data that would be nearly impossible to discern manually. Imagine a digital detective, tirelessly sifting through cosmic clues, identifying signals hidden within the noise. This collaboration between human intuition and artificial intelligence is revolutionizing astrophysics, allowing us to make sense of the universe in ways we never thought possible. As we look ahead, the future of black hole research is brimming with possibilities. The upcoming generation of observatories, equipped with cutting-edge technology, will enable us to probe even deeper into the mysteries of the universe. Future missions aim to study the environment surrounding black holes, such as the behavior of matter in accretion disks and the jets of particles that can shoot out at near-light speeds. These jets carry energy and information across vast distances, influencing star formation and the evolution of galaxies. Moreover, the quest to understand the fundamental nature of black holes is far from over. Concepts such as Hawking radiation, proposed by the brilliant physicist Stephen Hawking, suggest that black holes may not be entirely black after all. They could emit radiation, slowly losing mass over eons and potentially evaporating completely. This idea challenges our perceptions of these cosmic titans and raises questions about the ultimate fate of matter consumed by black holes. Imagine a universe where black holes are not just endpoints, but rather gateways to new realms of understanding. The interplay between black holes and the surrounding matter could hold answers to some of the most profound questions in physics. How does gravity behave at its most extreme? What are the implications of black hole entropy? These inquiries are not merely academic. They echo through the very fabric of our existence. As we stand on the precipice of this new era in astrophysics, we are reminded of the words of the visionary physicist Carl Sagan, who stated, "Somewhere, something incredible is waiting to be known." Each discovery, each breakthrough, brings us closer to unraveling the cosmic enigma that is the black hole. The journey is both exhilarating and humbling, inviting us to ponder our place within this vast universe. What will we uncover next? The universe is full of secrets, and black holes are among the most profound, challenging us to expand our horizons and redefine our understanding of reality. With the rapid advancements in technology and the persistent curiosity of scientists, we find ourselves at the dawn of a new age in black hole research. The interplay between gravitational waves, the power of artificial intelligence, and the relentless pursuit of knowledge paints a hopeful picture for the future of astrophysics. As we continue to explore these celestial giants, we may yet uncover the keys to understanding not just black holes, but the very nature of the universe itself. What incredible revelations lie in wait for us in the depths of space? The journey through black hole research brings us to the intricate interpretations of black hole mergers and collisions, which are now understood to be more than mere cosmic events. Each merger is a story of transformation, revealing the complex dynamics of these massive entities. As two black holes spiral together, they create a gravitational wave signal, a unique fingerprint of their interaction. This signal carries information about the masses, spins, and even the distance of the merging black holes, providing invaluable data that helps astrophysicists to refine their models of such violent processes. Consider the aftermath of a black hole merger. The collision doesn't simply create a larger black hole, it also releases immense quantities of energy in the form of gravitational waves, which ripple through the cosmos. This energy is a byproduct of the extreme acceleration of massive objects, demonstrating the profound effects of gravity. Imagine the universe itself vibrating in response to these colossal events, a cosmic symphony reflecting the chaotic dance of matter and energy. The study of these mergers has also unveiled surprising insights into the nature of black holes. For instance, the spins of merging black holes can vary widely, hinting at their diverse origins. Some black holes might result from the remnants of massive stars, while others may be born from different processes, such as the merging of smaller black holes. This variability prompts fascinating questions about the evolutionary paths that lead to such mergers. What stories do these black holes carry from their past? How do their interactions shape the galaxies in which they reside? Artificial intelligence has emerged as a powerful ally in deciphering the complexities of black hole mergers. By analyzing vast amounts of data generated from gravitational wave observations, AI algorithms can identify patterns and anomalies that human researchers might overlook. Imagine an intricate web of data, where the slightest variations can reveal significant cosmic truths. AI acts as a guide through this labyrinth, enabling scientists to focus on the most promising leads and refine their interpretations of the data. One notable development is the creation of machine learning models that can predict the likelihood of a merger based on the characteristics of black holes. These models are trained on past observations, learning to recognize the subtle signatures of impending collisions. As a result, researchers can not only detect existing mergers, but also anticipate future events, enhancing our ability to understand the dynamic landscape of the universe. The future of black hole research is rich with potential, as scientists strive to deepen their understanding of these enigmatic entities. Upcoming projects and missions are set to delve into the environments surrounding black holes, examining the behavior of matter as it spirals into these gravitational abyss. The accretion disks, swirling clouds of gas and dust, serve as laboratories for testing theories of physics under extreme conditions. What secrets might they reveal about the fundamental forces that govern the universe? Moreover, as we develop more sophisticated instruments, we can explore the jets of particles ejected from black holes at nearly the speed of light. These jets, composed of charged particles, extend far beyond the accretion disk and can influence the formation of stars in the surrounding regions. Imagine these jets as cosmic lighthouses, sending out energy and information across vast distances. They play a crucial role in the evolution of galaxies, illustrating how black holes are not merely destructive entities, but also pivotal players in cosmic ecology. As we ponder the future of black hole research, we are reminded of the profound implications these studies hold for our understanding of the universe. The exploration of black holes is not just a quest for knowledge. It is an inquiry into the very nature of reality itself. Each discovery beckons us to reconsider our place in the cosmos, challenging us to think beyond our terrestrial experiences. In the spirit of inquiry, we might ask, what fundamental truths about our universe lie within the shadows of black holes? As we push the boundaries of our knowledge, we inch closer to answering questions that have lingered in the minds of scientists and philosophers alike. The fusion of advanced technology, collaborative research, and unyielding curiosity promises to unveil new dimensions of understanding. As we consider the journey ahead, it becomes clear that the exploration of black holes offers more than just insights into these cosmic giants. It invites us to reflect on our relationship with the universe. Each new discovery is a reminder of the interconnectedness of all things, how the remnants of ancient stars, the gravitational waves of colliding black holes, and the very fabric of space-time weave together in a grand cosmic narrative. In the upcoming chapters of our exploration, we will witness how these scientific breakthroughs not only deepen our understanding of black holes, but also illuminate the paths of future research directions in astrophysics? What awaits us in the uncharted territories of the cosmos? The answers may lie in the very heart of black holes, waiting to be uncovered by those brave enough to embark on this celestial quest. The exploration of black hole mergers and the insights they yield extends into a myriad of fascinating interpretations. Each event is not merely a collision, but a profound cosmic interaction that reveals the complexities of our universe. When two black holes spiral inward, the gravitational forces at play are so immense that they warp space-time itself. This bending creates a unique echo, a gravitational wave that carries with it the history and characteristics of the black holes involved. Imagine this wave as a message sent across the cosmos, a whisper of the drama unfolding in a distant galaxy. The analysis of these gravitational waves allows scientists to glean critical information about black holes, including their masses and spins. These metrics are essential for understanding how such massive entities evolve over time. For instance, the spins of black holes can indicate whether they formed from the collapse of a single star or as a result of mergers between smaller black holes. This understanding is vital, as it aids in constructing a more comprehensive picture of black hole evolution and the role they play in the life cycle of galaxies. Consider the metaphorical journey of a black hole from its birth to its ultimate collision. Each merger not only reshapes the involved black holes, but also has broader implications for the surrounding cosmic environment. The energy released during these events can trigger processes that influence star formation and the dynamics of entire galaxies. It's a striking reminder that black holes, often perceived as destructive forces, also contribute to the cyclical nature of the cosmos, nurturing as much as they consume. Artificial intelligence is increasingly becoming an invaluable tool in unpacking these complex narratives. The sheer volume of data generated from gravitational wave observatories can overwhelm traditional analytical methods. Yet, through the lens of machine learning, researchers can identify patterns that would otherwise remain hidden. Imagine a sophisticated algorithm combing through years of data, discerning the subtle signatures of impending black hole mergers. This synergy between technology and human understanding not only accelerates our discoveries, but also enriches the narrative we weave around these cosmic phenomena. As we gaze toward the horizon of astrophysics, the future is full of promise. New observatories, equipped with enhanced sensitivity and resolution, are set to revolutionize our approach to studying black holes. Upcoming missions aim to explore the environments surrounding these entities more closely, examining how matter behaves in the extreme gravitational fields near black holes. This inquiry could uncover the mechanisms by which black holes influence their surroundings, potentially illuminating the pathways of galactic evolution. Moreover, the quest to understand black holes pushes the boundaries of theoretical physics. The enigmatic concept of Hawking radiation, which posits that black holes can emit particles and ultimately evaporate, invites us to reconsider the very nature of these cosmic giants. What if black holes were not the eternal prisons we once believed them to be? This notion raises profound questions about the fate of matter and information consumed by black holes. Are they truly annihilated, or is there a possibility of transformation into a different state of existence? In this grand tapestry of cosmic exploration, the interplay between black holes and fundamental physics becomes increasingly evident. Each discovery beckons us to reflect on the nature of reality itself. As we delve deeper into the mysteries of black holes, we are not merely studying isolated phenomena, we are engaging in a dialogue with the universe. Questions arise. How do black holes affect the very fabric of spacetime? What does their study reveal about the fundamental forces that govern our existence? As we ponder these profound inquiries, we are reminded that the pursuit of knowledge is an ever-evolving journey. The tapestry of discoveries, woven through centuries of inquiry, continues to expand. Each step forward in understanding black holes not only illuminates these enigmatic entities, but also sheds light on the broader questions of existence, time, and the nature of the universe itself. What remarkable truths await us as we continue this celestial quest? The answers lie in the depths of space, waiting to be unveiled by those willing to embrace the unknown. Chapter 10: The Limitless Possibilities, What Lies Ahead in Black Hole Research. As we look toward the future of black hole research, we find ourselves surrounded by a multitude of ongoing questions and challenges that beckon for exploration. Each mystery deepens our understanding of the universe, yet simultaneously stretches the boundaries of our knowledge. How do we accurately measure a black hole's mass? What can we learn from the behavior of matter as it approaches the event horizon? These questions, woven into the very fabric of black hole physics, challenge even the brightest minds. The immense gravitational forces within black holes pose significant difficulties for scientists. How can we study something that is, by its very nature, invisible? This paradox invites innovative solutions from researchers worldwide. The advent of advanced telescopes and gravitational wave detectors has opened new avenues for observation, allowing scientists to infer the existence of black holes by studying the effects they have on nearby stars and gas. A captivating example is the observation of stars orbiting around the invisible mass of a supermassive black hole at the center of our galaxy. Scientists have meticulously tracked their orbits, unlocking secrets about the black hole's mass and influence. This meticulous work underscores the relentless pursuit of knowledge in the face of cosmic enigma. As we gaze into the future, the horizons of black hole physics are expanding, revealing the potential for groundbreaking discoveries. New technologies are on the brink of transforming our understanding of these cosmic giants. Imagine a future where we can directly observe the event horizon of a black hole, capturing images that reveal the swirling accretion disks and the mesmerizing jets of energy that shoot out into space. The Event Horizon Telescope has already provided humanity with its first image of a black hole's shadow, a historic milestone that demonstrates our growing capabilities. The excitement of such advancements hints at a future where the mysteries of black holes may soon be unveiled in ways we once believed were impossible. Interdisciplinary approaches are also emerging as vital in the exploration of black holes. Astrophysics, mathematics, and even philosophy converge to create a rich landscape of inquiry. Theoretical physicists collaborate with mathematicians to develop complex models that describe the behaviors of black holes, while philosophers ponder the implications of these discoveries on our understanding of reality. How might the nature of black holes influence our concepts of time, space, and existence? The interplay between these disciplines fosters a holistic understanding, urging researchers to think beyond traditional boundaries. As we consider the future of black hole research, the potential for groundbreaking discoveries becomes increasingly apparent. The study of black holes may very well lead to revelations that reshape our understanding of the universe itself. What if, through our exploration, we uncover new forms of energy or insights into the fundamental forces that govern existence? The pursuit of such knowledge is not merely an academic endeavor. It is a quest that ignites the imagination and beckons us into the depths of the cosmos. The recent emergence of quantum gravity theories offers a tantalizing glimpse into the potential for new understanding. Could these theories bridge the gaps between general relativity and quantum mechanics, allowing us to glimpse the inner workings of black holes. The concept of entanglement, where particles remain connected across vast distances, raises profound questions about the nature of reality itself. How might this phenomenon manifest within the extreme environments of black holes? The answers to these questions hold the promise of reshaping our understanding of both black holes and the universe at large. The interplay between black holes and dark matter also presents a realm of possibilities. Dark matter, which comprises a significant portion of the universe, yet remains largely undetectable, may interact with black holes in ways that we have yet to comprehend. The search for answers could lead to revelations about the very structure of the cosmos and its evolution. Imagine a future where we can unravel the mysteries of dark matter, linking it intricately with the enigmatic nature of black holes. Moreover, breakthroughs in technology and computation are paving the way for enhanced simulations and models that may illuminate the behavior of matter in extreme gravitational fields. High-performance computing allows scientists to simulate complex interactions that occur near black holes, providing insights that were previously unattainable. These simulations serve as invaluable tools, enabling us to visualize phenomena that challenge our intuition. They offer a glimpse into the chaotic dance of matter and energy, revealing how black holes may influence their surroundings in unforeseen ways. As we continue to explore the depths of black holes, we must also remain cognizant of the philosophical implications of our discoveries. What do black holes teach us about our place in the universe? They act as both destroyers and creators, illustrating the cyclical nature of existence. The insights gleaned from their study can inspire not only scientific advancement, but also a deeper appreciation for the interconnectedness of all things. They remind us that the universe is a vast, intricate web, where every thread is interwoven with the other. The potential for interdisciplinary collaboration extends beyond traditional scientific fields. Artists, writers, and educators are increasingly engaging with the subject of black holes, infusing their work with the wonder and mystery that these cosmic phenomena evoke. How might art and literature enhance our understanding of the cosmos and inspire the next generation of scientists? The fusion of creativity and science holds the power to ignite curiosity, urging individuals to explore the unknown with open hearts and minds. As we stand on the precipice of discovery, the future of black hole research gleams with promise. The ongoing questions and challenges serve as a reminder of the vastness of the cosmos and the limits of our understanding. Yet, with each step forward, we uncover new layers of complexity and beauty that defy our expectations. The potential for groundbreaking discoveries looms on the horizon, waiting for intrepid explorers to delve into the mysteries that lie ahead. Imagine the day when we can peer directly into the heart of a black hole, witnessing its majesty and unraveling its secrets. The possibilities are boundless, and the journey is as important as the destination. The universe beckons us to explore, to question, and to dream. With every observation and every theory, we inch closer to understanding the profound nature of black holes and their place in the grand narrative of existence. The ongoing questions and challenges in understanding black holes are not merely academic. They resonate with the very essence of human curiosity. As we probe deeper into these celestial phenomena, we encounter puzzles that stretch our imagination. How do black holes influence the formation and evolution of galaxies? What role do they play in the life cycle of stars and cosmic matter? Each inquiry opens the door to new realms of knowledge, weaving an intricate narrative of cosmic dynamics that captivates both scientists and enthusiasts alike. The future of black hole physics is poised for a renaissance of discovery. With advancements in technology, we find ourselves on the cusp of revolutionary methods for studying these enigmatic entities. Imagine a world where quantum computers could simulate black hole behaviors, allowing us to analyze gravitational interactions with unprecedented precision. The integration of artificial intelligence into astrophysical research could enhance our ability to process vast quantities of data, enabling us to identify nuanced patterns that might otherwise elude our understanding. As the boundaries of technology expand, so too does the potential for interdisciplinary collaboration. The convergence of physics, computer science, and philosophy fosters a rich environment for exploration. Researchers are increasingly recognizing that insights from one field can illuminate questions in another. Imagine a mathematician collaborating with a philosopher to explore the implications of black holes on our understanding of time and existence. Such partnerships could lead to a more holistic grasp of the universe, where scientific inquiry is complemented by philosophical reflection. Moreover, the quest to comprehend black holes invites innovative experimental techniques. Scientists are developing new instruments designed to detect the faint signatures of black holes, such as their gravitational waves or the high-energy radiation emitted by matter as it spirals into the abyss. Consider the impact of the next generation of space telescopes, equipped with advanced sensors capable of capturing the subtle nuances of cosmic phenomena. These tools will empower us to investigate the mysteries of black holes with a clarity previously thought unattainable. In this landscape of discovery, the potential for groundbreaking revelations looms large. As researchers delve into the relationships between black holes, dark energy, and the expansion of the universe, they may uncover connections that reshape our understanding of cosmic evolution. What if black holes serve as seeds for the formation of new galaxies, influencing the distribution of matter across the cosmos? Such scenarios spark the imagination and challenge our perception of the universe as a static entity. The study of black holes also holds promise for unveiling the fundamental workings of the universe. The interplay between black holes and dark matter, a component that makes up a significant portion of the cosmos, yet remains elusive, could lead to transformative insights. How might these mysterious forces interact, and what implications would that have for our understanding of gravity itself? As we venture into this uncharted territory, we are reminded of the importance of maintaining an open mind and embracing the unknown. As we contemplate the future of black hole research, we must remain alert to the philosophical implications that accompany our discoveries. Black holes challenge our notions of causality, time, and the very fabric of reality. They force us to confront profound questions about existence itself. What happens to information that falls into a black hole? Does it simply disappear, or could it be preserved in some form? These inquiries not only stir the scientific community, but also resonate with anyone who has gazed up at the night sky and pondered their place in the universe. The potential for interdisciplinary exploration extends even further, as artists and educators engage with the themes surrounding black holes. Imagine a world where stunning visual art captures the complexity of black hole physics, inspiring audiences to consider the beauty of the unknown. Educational initiatives that blend art and science could foster a new generation of thinkers who are as comfortable with the language of creativity as they are with the equations of physics. Engaging diverse perspectives enriches our understanding and deepens our collective appreciation for the cosmos. The limitless possibilities that lie ahead in black hole research are a testament to the resilience of human curiosity. As we continue to unravel the mysteries of these cosmic giants, we embark on a journey that transcends individual disciplines, inviting us to explore the interconnectedness of all things. Each discovery, each question answered, leads us further into the depths of understanding, illuminating the path ahead. In this grand exploration, the universe stands as both a canvas and a stage, where the forces of nature play out their drama. With every new insight, we weave a deeper narrative that connects us to the cosmos and to each other. The future of black hole research is not merely a pursuit of knowledge. It is an invitation to marvel at the wonders of existence and to embrace the profound mysteries that await us beyond the horizons of our current understanding.